So I'll be talking about this vague topic about developing graphics technology for non-AAA games, which is like if you're making a small or indie or casual game or just about anything that doesn't cost 10 to 20 to $100 million to make, then quite likely you need to develop graphics technology a bit differently from those big budget games. So I'll be talking about that a bit. And I'm Aras Pranckevičius. I'm the lead graphics programmer at Unity Technologies. And I was involved with the Nesnausk demo group, but we just didn't happen to make any demos for the last, I don't know how many years, 5 or something. And most of this talk will be based on my experience of working at Unity. And at Unity, we make this game engine for smallish games. So your own technology might be different, or your own situation might be different, or your game might be different, anything might be different, so just keep that in mind. And I'll be talking about what graphics hardware can or should you target while making a game, what features can you use, how to make a game or not make a game cross-platform, about stability problems, and how to test your game for graphics problems. So first, let's start on the hardware. And very often especially at conference presentations, you see everyone pushing that you should use this DirectX 11 or DirectX 100 or whatever is current now, and your game absolutely needs that, otherwise it just won't be successful at all. Or that if you won't support 64-bit Windows, you're doomed because next week everyone will be using that. Or I don't know, that forget about graphics cards made 1 year ago. We have GeForce GTX 2000 or something now, and you should only target that. And the reality, especially if you're making a small game, is a bit different. Because small games, as a rule, don't target high-end systems. Most often, they just can't have the requirements of Crysis or something similar. And you should basically look at the data of what people actually have. And there's not a lot of sources of data. Like, for example, 2 I know is Steam hardware statistics and Unity hardware statistics. Steam is more sort of big, more hardcore-oriented, I would say, because especially casual gamers don't even know that Steam exists. And Unity is probably more small and casual-oriented. And the next few slides will be based on Unity statistics. And the statistics we started gathering more than a year ago. And by now it has like 10 to 12 million hardware entries. So the actual pool is quite large, and we can actually make some reasonable approximations about what people have. So coming back to those, your game needs DirectX 11 points. Well, DirectX 11 is not even out yet. So, for example, DirectX 10, by now, about 10% of casual gamers can actually use that, meaning that they have Vista, Windows Vista or later, and they have DirectX 10 capable graphics card. And that number is rising, but it is rising, well, not very fast. If the trend continues to be the same, then maybe in 5 years, half of the population will be able to use DirectX 10. And it's even worse for 64-bit Windows. Almost no one is using that yet. Of course, in some points, everyone will be using that, but that will probably happen in 10 years, I don't know. And this is the graph, basically, of what performance of the graphics cards are there. And something like your regular, not very bad laptop probably has GeForce 9600, and actually most people have graphics cards which are even 5 times slower than that. This is a graph of bandwidth, GPU bandwidth in gigabytes per second versus percent of the people that actually have that. And most of the high-end cards, almost no one has that. So basically, a netbook or a low-end laptop with a really bad graphics card is your typical user. And so it's your choice. Which hardware do you target? And it's really hard, and it's really boring to target those crappy machines. And it's not interesting. You can't really use interesting techniques there. You can't use whatever is the latest research. And everything runs just oh so slowly on those machines, but it's just the sad reality. But on the upside, buying those machines is cheap because those are low-end machines. And you can port your game to handheld or mobile platforms easier because those are sort of similar in the specifications. And for the high-end gamers, you can just implement some features which are very, very expensive and sort of just need a checkbox somewhere, like use this screen space, ambient, whatever radiosity thing, and it will make your game run 10 times slower and look a bit better. Next is what graphics features can you actually use? And here's again the stats we have. So basically, this graph is saying which shader model is supported by how many machines. And you can see that the hardware capabilities are getting better over time, but quite slowly as well. OK, I'll just say that in text. And fixed function hardware, which is like almost 10-year-old hardware, is still at 20% of the market. And the rest is actually quite good hardware in terms of capabilities. And this thin, dark green line is DirectX 9 hardware, which is almost dead by now. So when you're making your technology, it makes sense to target fixed function hardware, but it probably doesn't make sense to do separate shaders or separate rendering paths for DirectX 8, which is pixel shader 1 point something hardware, because no one has that by now. And I don't really know why that happened. My theory is that there never was a low-end graphics card of DirectX 8. Before that, there was GeForce 2 and integrated Intel cards, and after that, there was GeForce FX 5200 and again integrated Intel cards. And everything DirectX 8 was high-end cards at that time. Well, OK, I already said that. So the rest of the market is actually, well, it's not too bad in terms of capabilities. You can have Pixel Shader 2.0. It's just the capability is there, but the cards are probably very slow at executing that. Like Intel integrated GMA 950 graphics card, it can support shaders, no problem. It's just, well, not very fast. And also keep in mind that shader model 2.0 support doesn't imply that the graphics card supports floating point textures or multiple render targets or other of those features. I'm talking about Intel cards in particular, because they don't support them. So in the end, it probably makes sense to implement 3 different rendering paths in your game. One is it displays something. It's just probably not pretty, but you can actually play the game, which targets really old graphics cards or really slow graphics cards. And it doesn't have shaders. It uses pure fixed function. It doesn't have any fancy effects. It's just it displays something. The next is where you can actually use shaders, but it is targeted at graphics cards which are very slow or don't have any of the fancy capabilities, which is actually the largest percent of the market, which is integrated Intel cards and low-end, again, integrated NVIDIA ATI graphics cards. And then you can choose to implement some high-end rendering path for fancy hardware if you want to, or if you want to express your graphics programmer desire to implement whatever. So yeah. When you're thinking about whether you should support cross-platform, when you're making a game, it's actually, you can either say, I will just do this game for a single platform, whether that is iPhone or whether that is Windows or whether that is XBLA or something. Or you can just say, I'll make this game or my technology for multiple platforms. But so once you answer this question, you just need to implement that. And there's one particular myth on the internet, especially that, oh, OpenGL is cross-platform. That means I will use OpenGL and my problems will be solved. And that, unfortunately, doesn't quite work because, well, OpenGL works on platforms which are regular PC, just with different operating systems. And that doesn't encompass all possible platforms. For example, on the consoles, OpenGL, well, doesn't exist. On mobile platforms, there's OpenGL ES, which is a slightly different thing. And in my experience on Windows, OpenGL is just unusable because of really bad driver quality. But it's actually not so hard to support multiple platforms, especially if those platforms have similar hardware. Because the hardware is very similar. All your game does is it contains some data, which is like textures, which are a bunch of pixels, and meshes, which are a bunch of vertex data. And all you need to do is just feed that into the API that exists on that platform, which is not hard, which is actually way easier than, for example, supporting the same platform with 10 times different hardware configurations, because then you actually need to maybe even produce different data for your game. For example, low detail models and high detail models or something like that. So if you decide to support multiple platforms, you just support the things that your game needs, and don't try to implement this uber generic API that would allow anything to run on anything, because that will just lead nowhere. Again, for the stability thing, the #1 problem on the PC is broken graphics drivers. At Unity, I think 2 years ago, we only had OpenGL support, both on Mac and on Windows. And of all the game crashes, 95% or something were in OpenGL drivers. So at that time, we decided, let's do DirectX 9-based rendering system, and then the crashes got down a lot more. So that was 2 years ago. Maybe the situation is different now, but I don't know, I just lost my hope for OpenGL being stable on Windows. And even on platforms where it's the only choice, for example, on the Mac, you just have no other choice than to use OpenGL. Well, there Apple likes to break OpenGL in various ways, especially on major OS releases. For example, there was OS 10.4, Tiger or something, and they had OS 10.5, and in the first 2 or 3 minor revisions of that, it was just horribly broken. And I would guess the same will happen this fall when they will release the next major update. And some of those drivers are just totally, absolutely broken. Like in Unity code base, we have this variable saying totally broken, which means if you try to do anything, it will just hang up the machine. And just like there's no way to use that basically at all. And it's just very, very sad. But that's life. And if you're making small games, the problem is that the drivers that are out there, those driver manufacturers won't fix the drivers for you. For example, for high-profile games, they actually tune and optimize the drivers so that they run benchmarks in this game a bit better. Or they even fix your broken game because the game does some bad things, and so they work around that in the driver because maybe ATI doesn't want that on their graphics cards. This game doesn't work while it works on NVIDIA graphics cards. But if you're making small games, you're this just small guy, then no one actually cares about you. And even when you contact the GPU manufacturers, saying, I have this problem, what should I do? The most often the reply you get is, sorry, we are super busy with these high-profile games now, ask us again in 2 months. And in 2 months, the same happens all over again. So basically, you're left on your own. If you have any driver problems, then it's best to just work around them yourself. But the good news is that drivers are not actually that bad. It's probably the number one stability problem, but well, it's not that bad. Maybe, I don't know, maybe 1% of your game players will crash somewhere, but it's a lot, but it's still just 1% or something. And driver quality is actually getting better over time, so it's not that bad. When it comes to testing, what we do at Unity, we just buy a lot of graphics cards, and then we run tests on them. Now, there's no problem with that by itself. It's just a bit annoying because most of the graphics cards that people have are actually integrated graphics cards, so you can't just buy one machine and 10 graphics cards. You actually need to buy 10 machines and just stack them in a row and just have someone running the tests on them. What we do have is we have a bunch of like functional tests, each testing some particular feature, and then we have a bunch of more complex testing like features in combination. So this helps to isolate driver bugs when they just don't support something specific very well. For example, they might break when you use rendering to texture with bitmaps or whatever. And it also helps us a lot when we break something while we are developing. For that, we run the same tests as regression tests, run them not on the real GPU, but on DirectX software rendering, dump a lot of screenshots and compare them against sort of the known correct screenshots. And we have this continuous integration testing server where we can immediately see basically each day whenever someone broke something in the code base. And I like that. That helps a lot. So that's about it. In summary, what I was trying to say probably is that just don't believe all the hype you can see at the conferences. It's fine to look at that. It's fine to experiment with those techniques, and it helps a lot. And most of them will be very practical in 5 years or something, even for small games. It's just for small games, especially, it's very important to run on the low-end machines. And you can actually use features which are not that bad in terms of capabilities, and do all the testing yourself because, well, no one else will test it for you. So that's it. Any questions?
Any questions? No one?
Okay. No one understands anything, I guess.
So thank you very much. And
oh, that was short. We got 40 minutes left.
that's true. Yeah.
Should I dance or something? I don't know.
I think it was very good, so that's it.
Okay.
So after 35 minutes, we will have the next seminar. Thank you.